In this tutorial, we will look at Chapter 12, Worksheet number 2, and see how question number 1 to be answered. If you look at question number 1 on the worksheet, you should understand the question, which is you have a block, a copper block, which is about 105 degrees Celsius. And that block is being added into a cup of water, and the water is initially at 20 degrees Celsius. Now, before we do any kind of math calculations or think mathematically, just think about it using your common sense. If you have a hot copper or some kind of metallic block, and then you add that into a cup of cool, cold water, what's going to happen? So what's going to happen is that the temperature of the water is going to go up, and the temperature of the copper block is going to go down. So we would expect that there will be some kind of energy gaining by the water and some kind of energy losing by the copper block. So we want to know what's the final temperature. That's the question. We would like to know what is the final temperature. And one thing that you have to understand is that at the end, okay, when the temperature finally is stabilized, what's going to happen is that the temperature of the water should equal to the temperature of the copper block. Okay? Now, we learned in the first semester that the energy cannot be created or destroyed, but can only be transferred. And what we are seeing here is a transfer of energy from the copper block to the water. We are going to assume that no energy loss or transfer between the water and the air and the water with the container. So the only energy transfer possible in this process is going to be assumed to be that between the copper block and the water. So let's look at here, the law of conservation of energy. So the amount of energy lost by the copper block is all going to the water. Okay? So let's make a statement, a mathematical statement. So I'm going to write this. The heat energy gained by whatever object should equal to the heat energy lost by another object. Okay, so this is the statement this is the statement for the law of conservation of energy. Now, but when you look closer, this statement doesn't make perfect sense, because when we do the calculations of just the energy gain or energy lost, we realize that sometimes the number we calculated would be positive, sometimes it will be negative. And the reason why sometimes it will be positive or negative, it all depends on how or the direction of the energy flow. If something is gaining energy, that value tend to be positive. So let me use some red marker to mark in positive. Okay? And then, for the heat energy lost, if you have energy released or lost, that number calculated should be negative. And now we are saying that they are equal to each other. Now this doesn't make sense, because you have a positive number on the left-hand side of the equal sign and a negative number on the right-hand side of the equal sign. So there should not be an equality, because positive would never equal to a negative. So in order to make this equality make sense, both sides should have the same sign. Now, we understand that the magnitude, the number, will be the same, but it's just a matter of the sign. So what we do is that we are going to multiply -1 on the right-hand side. Now, you may ask, well, do you have to do the same thing on the left-hand side? Well, one thing I want you to understand is that before we multiply this -1, this is not an equality. We cannot write an equal sign. In order to write this equal sign, in order to make this equal sign reasonable, this is something that we have to do to justify. So this is the reason why we only multiply the -1 on the right-hand side to get our equation. So this is the concept behind the heat transfer, is that the heat energy gain is equal to the heat energy loss, and when we deal with it mathematically, we have to take the sign into account. The concept itself is not difficult. It's just the manipulation of the sign and those algebra work that may involve big numbers, decimals, units, and it is that part that makes the whole calculations very interesting. So I hope you understand the concept behind of the heat transfer based on the law of conservation of energy. In the next part, we will go ahead and take a look on the detailed calculations for this problem.